Hello, my name is METİN ARIDAŞIR. This is 37th part of explanation of my theory. As multi-electron atom, the carbon spectral lines WHOLLY certainly predicted by me, ARIDAŞIR. I computed carbon atoms' spectral lines values according to my theory and my formulas. Here, right side, my computations according to my theory and my formulas, and left side, data from NIST. And it goes on like this. Right side, according to my theory and my formula, my computations, and left side data from NIST. Okay. Yes, NIST, the source, data source, measurement experimental results sources, National Institute of Standards and Technology. Yes. There is no cloud, no dust, no uncertainty, no probability, and no indeterminism. All proton-tied, proton-bounded electrons are always both at rest, undisturbed, unexcited at their initial imbalanced wavelength and enlarging, shrinking, or at any different stopping step at a certain place and a certain linear velocity at the same moment for each situation. Whether proton-bounded electron, undisturbed, unexcited, or excited by free electron motion forms successive waves and enlarge or shrink, enlarges or shrinks, it's not important. According to my theory and my formulas, their places, wavelengths in all lines and their velocities always known by us according to my theory and my formulas. Here, left side, in order, okay, and between n equal to 5 and equal to 18. Here, between n equal to 5 and equal to 9, and equal to 5 and equal to 8, etc. When you see here and here, n equals 7, I'm so sorry, n equal to 7 and equal to 15, etc. When you see here, n equal to a number other than 1, here it means n is the number of free electron motion forms effective successive wave number that makes the bounded single cycle electron motion form enlarge. Especially the smallest wavelength proton-bounded, proton-tied electron motion form is determinative for the observation of spectral lines of atoms, according to my theory and my formulas. Remember, each line's values is single wave pulses, representative wavelengths. Here, single wave pulses, representative wavelengths. Okay? Now, notice that. Notice the successiveness and coherence. Successiveness. Result almost same. Okay? I have accounted margin of error, my computations error, margin of error is usually 1 in 1,000. So normal. And there are coherence and yes, wait a moment. Notice, yes, notice the successiveness and coherence. Yes, now here n equal to 1 between two steps, okay. From n equal 18 to n equal 5 shrinks, and when atom bounded electron motion form, carbon bounded electron motion form shrinks from n equal 18 to n equal 5, this single wave pulses representative wavelength, single wave pulse produced and pushed. Okay. Now, and between 5 and 9, and between 5 and 8. Okay. Look at that. And between 5 and 7. 9, 8, 7. Reducing. Okay. Sometimes another n steps mixing. But this is rule reducing number. In order. There are a kind of successiveness and coherence. Okay. Here. And again, right side my computations, left side data. Here. And between 7 and 15 in orderly, and between 7 and 14 new step, and between n8 and n29 reducing 28 n equal to 8 to n equal to 20. New step 9 from 22 to 9, from 17 to 9, from 16 to 9, from 13 to 9. Okay. New step from 31 to 12, from 14 to 10. Okay. This is different step, and 13 steps. Okay. $15, $14, okay. 17, 16, coherence, successiveness, yes. Same successiveness. 13, 29, 28, Okay, like this. And I have computed all of this according to my theory and my formulas, and especially the smallest wavelength, proton-bounded electron, is determinative for the observation of spectral lines of atoms. Now, I hope you see. Yes. Remember, lastly, I will say, and shortly, for instance, carbon atom has 6 electrons. Each of electron motion forms has different wavelength. And I accounted smallest wavelength. First proton-bounded, first proton-tied, smallest wavelength I computed from smallest ionization energy was what? Here are my computations. Yes, 2.5320 nanometer. Smallest wavelength of carbon atom. Smallest electron radius or wavelength of smallest electrons of carbon atom, lambda EI carbon 16 is equal to 2.5320 nanometer. Remember my formulas from former videos. I recommend you watching my former videos about this subject, and I recommend you have a look at my formulas. Yes. Have a good evening. See you later.